Alright, so for this question, question number 5, part A. Alright, so we want to check for first, we're given this function of gx, right, defined by two functions, two part. Okay, gx is equals to 3 when x is in between 2 and 8. Okay, and then this absolute value of 8 minus x over x minus 8 plus k when x is greater than 8. Okay, so now we need to find this value for k such that gx is discontinuous at x equals to 8. Alright, so this is what we are given over here is the case where it is discontinuous at x equals to 8. So we understand that if it is continuous, the first the rules that we need to follow is g of 3 is equals to the limit for x approaching, g of 8 over here. So the function of g when x is equals to 8 is equals to the limit of x approaching 8 for gx. So this is when it is continuous. So now we are looking for when it is discontinuous. So if it is discontinuous, meaning that now the equation that we are looking for is g of 8 is not equals to the limit of x approaching 8, okay, for gx. Alright, so in this case we only have x approaching, we only have two different functions, two different parts, right? So for g of 8, this also meaning this is also the same value as x approaching 8 from the left. Okay, so this one x approaching 8 from the left. Alright, so for this one on the right hand side, we will take this one as x approaching 8 from the right hand side so that we can use the second part of gx over here. Okay, so for the function when g of 8, okay, the value is equals to 3 over here. So if this is equals to 3, okay, we want to check for, so this side we will use this function, okay, limit x approaching 8 from the right. So this is the function that we are looking for, 8 minus x and then x minus 8 plus k over here. Okay, so when we have it like this, so what we're gonna do next is, okay, this left hand side will just stay the same. So pretty much we will operate with the value for the right hand side. Okay, so we will have over here limit of x approaching 8 from the right. Okay, so if it is from the right over here, we can change that to negative. Alright, and then we have 8 minus, okay, so if you put 8 minus x over here, okay, so we will take the negative value, right, and then this one is divided by x minus 8, okay, and then we have this plus k over here. Okay, so the next line that we have is x is 3 is not equals to, so if we substitute this, if we rearrange this value, we will have over here, okay, so if we double check here, we will get that. Okay, so kalau if we factor out negative x over here, okay, we can simplify this so that this will just become 1 plus k. Okay, so if you look at this one, you factor out again negative. Okay, this one, the first one, we factor out negative from this absolute value function over here. Okay, and now if we factor out negative again, so that you will get, okay, negative of negative again. Okay, so that will be a positive actually. How do I write this? So that will just be a positive of x minus 8 over here, and then we divide by x minus 8, okay, plus k. So I factor out again negative over here. Right, so we are now just left with the limit of x approaching 8 from the right. This will just be 1 if we simplify this. So we have 1 plus k. Right, so if you look at this function that we are left with over here, now we don't have any more term of x, so that is just gonna be 3 is not equals to 1 plus k. Alright, and if we rearrange this, k is not equals to 2 over here. Alright, so this is the value of k, values of k. So k can take all values except for 2 because it is discontinuous at x equals to 8. Right, so this is for question 5 part A. Now, if we look at question part B, so we want to determine whether fx is continuous at x equals to 3. So if you still remember, we have three conditions for continuity. First, you have to check f of x must be, let's say the continuity we want to check is at c. Okay, so f of c must be defined. Okay, that is the first condition. Okay, and then the second one, okay, so the limit of fx, okay, when x approaching c from the left must be equals to the limit of x approaching c from the right of fx. Okay, so this must be equal so that exists, so that the limit of x approaching c of fx exists. Okay, and then the third one, the third condition that it must satisfy is f of c must have the same value with the limit of x approaching c for fx. Okay, so these three conditions that we need to check. So let's check this one by one for the continuity of fx at x equals to 3.